Assalamualaikum and hi to our lecturer Encik Ahmad Zulhusni bin Encik Muhammad. We are from group S3C and for our project F1 in school. Me, Ahmad Abdullah bin Muhammad, our team member Ahmad ZAIRY bin JAMALUDIN, RIZMANHADI bin NASRIL, Muhammad Safiq Andrian bin Muhammad ISAK, and AMSYAR QAYYUM bin BADRUL HISHAM. This is our company profile. Our company name is Exhaust Perang Corporation. Our company core business vehicle exhaust part designs. Our company mission is to produce high quality automotive ideas on Formula 1 vehicle. Next, to create a prototype of a Formula 1 machine. Next, to enhance the ability of automotive vehicles through designs. Our vision, to be one of a company that designs Formula 1 prototypes, parts and components that follows the standards of rule format in school 2020. And this is our company logo. Okay, next is our organization chart. Me, Ahmad Abdullah bin Muhammad, as the Chief Executive Officer. Next, Ahmad ZAIRY bin JAMALUDIN as Chief Financial Officer. Next, AMSYAR QAYYUM bin BADRUL HISHAM as Chief Operating Officer. RIZMANHADI bin NASRIL as Secretary, and Muhammad Safiq Andrian bin Muhammad ISAK as our company engineer. Okay. Next is our time plan. Our time plan starting from week 5 until week 13. Starting from week 5, we meeting for company profile. On week 6, we discussion for project, background and job distribution. On week 7 and week 8, we start to design ideas and design process final selection. From week 9 to week 12, we product development and evaluation on function and cost. Starting from week 13, we start to discussion on the product, structural and possible improvement, final conclusion about the product, final report writing, design review, CAD modeling, and lastly presentation. Chapter 1, Introduction and Background Theory. Starting from week 6, our project title is F1 in School. Our objective is to enhance automotive vehicle abilities, upgrade the automotive parts and components design, improve the material on the automotive parts and components. Our problem statement is car easily experiences drag through driving system. Car too heavy does increase drag. Lastly, more friction resulted due to car specification. Our scope of project focus on the automotive design specification with new design through the manufacturing of the car parts components due to some fault or unnecessary design. This is our team member job scope. Chief Executive Officer, me, Ahmad Abdullah. My job scope is communicating on behalf of the company, lead the development of the company's short or long-term strategies, create and implement the company organization vision and mission. Next, Chief Financial Officer, Ahmad ZAIRY bin JAMALUDIN, build financial models, analyze and prepare financial statement, reconciling income and expenses of the company. Next is Chief Operating Officer, which is AMSYAR QAYYUM bin BADRUL HISHAM. His job scope is to designing and implementing business operations, establishing policies that promote company culture and vision, overseeing operations of the company and the work of executives. Next, Secretary RIZMANHADI bin NASRIL. His job scope is to managing the weekly agenda, arrange new meeting and appointment, preparing and disseminating correspondence, memo and forms. Lastly, Engineer Muhammad Safiq Andrian bin Muhammad ISAK. His job scope is to develop new product, and lastly, design and produce the building block of machine, products of or system.
Hi, Assalamualaikum. I am QAYYUM bin BADRUL with student ID of B0919101991. We'll explain about introduction of our project until the chapter 2 of design processes through main body until rear wing. So let's move on to the introduction first. The F1 in schools car is a design and manufactured according to the regulations of F1 in schools track. The car is powered by a single 8 grams compressed air cartridge that will enable the car to travel to 20 meters distance withstanding forces of launch acceleration, track traversing, and physical deceleration. So during the race, the car or the prototype will accelerate first by the help of the air cartridge function that will make the car travel in the track, linear track. This will be consist of a straight line race, and then physical deceleration, which means that after travel of the vehicle or the prototype, it will experience a deceleration at the end of the race. Alright, that's for introduction. Next we move on to the parts function. So what do we have in our parts of the prototype? Firstly, we have the main body. The main body, a single uninterrupted piece of F1 model block material existing rear of the front axle center line and encompassing both the virtual cargo and compressed air cartridge chamber. So on the main body, there will be a figure that drawn basically from a block. Then we designed various type of, for example, the hole for the drive shaft and the air chamber cartridge. Also virtual cargo, there is a hollow area in the main body inner side. Okay, next is the secondly compressed air cartridge chamber. It is a cylindrical shape or cylindrical clear space bounded around its inner circumference and one end by car body only. This is where the compressed air cartridge is placed for launching. So the compressed air cartridge chamber, a cylinder shape and bounded around its inner circumference, so it will be designed to the inner circumference. It will not cause the outer circumference to change, so we make another inner circumference for the cartridge air chamber. So the cartridge chamber will be functional with the compressed air cartridge during the race. So thirdly, we have the tire. We know that a tire has 3 basic functions: to carry, guide, and transmit. So to carry means that it carry the prototype to move along the pathway. Next, guide. So with the tire, it will guide the prototype to move along the to move along the pathway during the racing or the driving, and then it will transmit. So on the axle, it will transmit the rotational energy to the wheel, or the tire will transmit energy to the bearing and the drive shaft. For sure, the rotational energy will be transmitted firstly from the tire, then to the wheel, and then to the drive shaft bearing, and lastly to the drive shaft and main body. So now number 4, we have the front wing. Front wing is the front wings control downforce, but they also control the total airflow around the Formula 1 car. So apart from front wing, we also have rear wing. Rear wing, the rear wings or spoiler creates what is known as downforce on vehicle's body. So front wing and rear wing is both two things that is also help in driving of the prototype, which firstly the front wing, we know that control the total airflow around the Formula 1 car, which means it will lower the air resistance from the front during the driving. Next, the rear wing, it is said that creates the downforce, during driving of the prototype. The air resistance that is being lowered will be useful to press the car downwards. So that means by pressing the car, they will resulting in downforce. Downforce is very good that will be used in the traction of the tire on the pathway or on the roads, but in this case on the pathway. So that's for front wing and rear wing. Next, we move on to the wheel. Wheel, a single part of or assembly of components, cylindrical in form, with its maximum circumference contacting the track surface, allowing for forward motion of the car through the rotation. So we know that this prototype will only move forward after being experiencing the air compress. So the wheel is a thing that is combined with the tire. So like in our daily life, there will be wheel and there will be tire. We will combine it together to perform a device that will rotate and guide and drive the vehicle. Next, we have the drive shaft. The drive shaft is a component of the drive train in a vehicle, with the purpose of delivering torque from the transmission to the differential, which then transmit this torque to the wheels in order to move the vehicle. So, by using the drive shaft, mainly in our daily life, it will be from the engine. So the engine, then to the gearbox. But in our case, for this F1 in School project, the main power of this project is the main power of this prototype is from the air chamber that will be experiencing air cartridge push. So for the drive shaft, as commonly we know, it will transmit energy through the tire and wheels that will drive the vehicle. Next, we have the drive shaft bearings. The drive shaft bearings function is to secure the drive shafts, and it should not be affected by vibration or harsh driving conditions in order to function properly and safely. So the bearing will make a smooth rotation for the drive shaft. As a result, it will resulting fluent or a fine driving or fine moving of the prototype. And next, we move on to the chapter 2. Chapter 2 is what we have done in week 7 until 8 about concept design sketching. And now we can see there is the main body. The main body, like I said before, it consists of a block that will be pad or pocket. From the diagram of our main body, we can see that there is 3 fins that being added of our design group mate, which was Ahmad ZAIRY designed it. So this will make our prototype looks stylish, and probably, or maybe for sure, it will be a fierce like car. So this is maybe an amazing style for a prototype of vehicle. Next, we have the air cartridge chamber, compressed air cartridge chamber. Like I said before, it is a part that being drawn by using inner circumference. So we make a new size of circle here, and then we pad it, and not pad, we pocket it, and that's how we make it. So it will be function by using the compressed air cartridge to push the air cartridge chamber, and also in the resulting will push the prototype to move in a straight line for 20 meters of distance. Next is the tire. Tire will be used and combined to the 4 wheels also in the project. So the tire is made of rubber, as commonly we know, consists of inner diameter and outer diameter. So the inner diameter we will make a pocket, while the outer diameter will be, firstly we will make a shaft first by of the outer diameter, then we'll make a new circle on the inner diameter, and then we pocket it to perform and result in drawing a tire. Next, after tire, we have rear wing. Rear wing is a part at the back side of the vehicle. This rear wing is drawn by our group mates ABDULLAH, while I drawn the tire just now. So the rear wing consists of plastic material in our project. So you can see that it is drawn by using mainly pad. So by using pad and some fillet, it will be a result of this rear wing. Also pocket is also used in this drawing of rear wing. So next, I will pass the presentation to Ahmad ZAIRY bin JAMALUDIN on our project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad ZAIRY bin JAMALUDIN, and I am going to continue presenting from where AMSYAR QAYYUM left off. So this is the part design for the front wing, and then we have the part design for the wheel, and this is the part design for drive shaft and the bearing. So this is the final design of the product that we produce, which already been produced. So this is the flowchart design product. So first is identify the product design, which is the model for F1, mini F1, and then we go to specify requirement, which is already been given by us, given to us by Encik Zulusni, and then finalize an idea, which is we make a tweak to the product design, our own variation for the product, and then we develop prototype design, which is we as a team already given our own part to produce, such as the front wing is another person, and the wheel is for another person, and then prototype analyzing, which is the volume stress, analyze the deformation, and the displacement analysis. And then we come to the final product, design product, which is finishing the prototype. This is the assembly view for the prototype, which is the product after assembling all the parts. So how the product work? So this F1 prototype powered by a single 8-gram compressed air cartridge. Also for the prototype body, we're using aerodynamic for reduced air resistance. Next, the bearing in this prototype will make the tire work smoothly. As you can see from the assembly, from the slide number 12, we have compressed air cartridge chamber, which is where the air cartridge installed. So the number of material, so we have 7 parts. The first one is the body, which is we have only one body, and we made it from material plastic. And then we have rim, which is also made from plastic. The rear and front wing also made from plastic, and the tire from the rubber. Draft shaft bearing, draft shaft and the chamber, draft shaft bearing and the draft shaft are made from steel, and lastly the chamber is also from plastic. So cost calculation. So the material cost for each unit per production is 50 ringgit, and then from the 50 ringgit, 10 of them is manufacturing expense, and then calculating total is 35 ringgit because the labor cost is RM 30 ringgit per unit, and then the sale price is 40 ringgit because the profit is 5 ringgit per unit. Okay, that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is ZAIRY bin NASRIL. Okay, I will discuss about the analysis of the part body. Okay, for the von Mises stress, what is the von Mises stress? Von Mises stress is a value used to determine if a given material will yield or fracture. For this part body, the von Mises stress is 6.98 E plus 003. Okay, next about the displacement. Okay, displacement is a vector image used to visualize displacement field pattern, which represent a vector field quantity equal to the variation of position vector of material particle of the system as a result of environmental action. So we can see the height is 0.00112. Okay, the next slide is a deformation. Okay, deformation or deform mesh image are used to visualize the finite element mesh in the deformed configuration of the system as a result of environmental action. Okay, as we can see is the deformation for the part body. Okay, next. Okay, for the tire, von Mises stress is at the 4.7 E. Next, this is a displacement for the tire at the height at the 0.04. For the deformation tire, yeah, okay, this is what we got. Okay, okay, for the rear wing, the von Mises that we got is a 6.46 E plus 003. Okay, so we can see it's bending at the center of the wing. Okay, next is this is a displacement for the rear wing. The higher is at the 0.005, 5.6 at the center of the wing. Okay, next is this deformation rear wing. Okay, for the front wing, the bomb mistress is at the 4.46 E plus 004. Next is the displacement for the front wing. The higher is a 0.006 0000669. Okay, and this is the deformation of the front wing. Okay, for the wheel, the von Mises stress is the 1.9 E plus 003. Next is the displacement wheel. Okay, this is the displacement wheel. Okay, in this slide, we can see this deformation of a wheel that we get. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Safiq Andrian Bmma ISAK. I will continue our presentation. This is the dry shaft result from our analysis von Mises stress that we apply the force about 1.4 Newton. So we apply the force at the middle, and the right on the left side we clamp the drive shaft. So that's why the shape look like this. So the result we got is 4.73 times 10 power of 6 Newton meter square for the von Mises stress. So this is the displacement vector. We got the result for displacement is 0.0034 millimeter. So this is the deformation that the shape look like this because we apply the force at the middle, and the climb we climb the drive shaft at the left and the right side. So next, the drive shaft bearing. So was Mises stress, we got about 2.7 times 10 power of 5 Newton meter square, that we apply the force at the middle hollow at the middle hollow bearing, and we clamp around the bearing. So that we got the maximum is 2.7 times 10 power of 5. So the displacement vector for the bearing, we got 1.3 times 10 power of negative 6 millimeter. So the deformation look like this because we climb the bearing around the bearing, and then we apply the force inside the hole. Alright, now I will present about the safety factor. Okay, the safety factor, the formula is ultimate stress over actual stress. So we calculate part by part. So the first part is main body. So the result for main body is 0.467. That means it's passed and not across the line. So the result is passed. So next, the tire we got is 2.15. The rear wing is 0.505, and the front wing is 0.731. Next, the wheels we got is 2.03, and the drive shaft is 0.833, and then the last part is drive shaft bearing. So drive shaft bearing is 1.43. So that means all our part is passed. And the second last, we got the safety, environment, and suitability. So the safety, first is safety code standard, not don't have a heat resistant on the F1 project. And the environment, using a recycled plastic, solid was it hazardous material. Suitability, process compatibility, process technology, readiness, raw material quality, assembly, stylish, ergonomic, maintenance, and repair. So lastly, conclusion. So the conclusion, based on the objective for this project, our group had gains the idea for conclusion. So this project design, our group get know to how to improve the design of component and part of this F1 car by improve the design of the part and component of this of the F1 car. Air resistance or drag can be minimized, and for the prototype body we use aerodynamic for reduce the air resistance. Besides, we also had improved the material used for the product, such as using the steel for the drasha bearing and plastic for the main body, rear wing, and rim front wing. The tire we use is rubber, and then by improve the material, it's help to reduce the weight for the car, thus reduce the drag. So this is our presentation. Before we close the presentation, I want to show the video montage that we create. So enjoy the video. Thank you.